Welcome to the debate. When we think about, the passage of time, we tend to rely on the rhythm of the seasons, like spring planting, autumn harvest.
Right.
It's just one of the most fundamental, unchangeable rules of human existence.
Well, the Earth tilts, the sun shines, and things grow. It's a fixed planetary cycle, right? Driven by biology and physics.
It was fixed anyway. Step into the agricultural centers of mid-2026, and that natural rhythm has been entirely overwritten.
Oh, absolutely.
We are currently looking at farms utilizing artificial super seasons. They're producing 10 crops a year, completely condensed into these hyper-optimized 5-week growth cycles.
Which is wild to even think about.
It really is. The laws of nature haven't changed, but our ability to engineer reality definitely has. And the control mechanism driving this agricultural revolution isn't, a new tractor. It's a box sitting on a desk. It's a cyber intelligence system processing environmental variables at a scale that the human mind simply cannot conceptualize.
Exactly.
So today we are framing our discussion around Professor Guy Lakeman's mid-2026 document, Cyber Intelligence 2026, Innovations and Structural Challenges. And it forces us to confront this central tension of our current era. Does the rapid advancement of mid-2026 cyber intelligence, which is marked by unprecedented scientific leaps and powerful open-source models, does that represent a net positive scientific triumph?
Or, on the flip side, do the severe structural failures in standards, corporate leadership, and biased implementation fatally undermine all of those technological gains?
Right, and my position is that the raw development of knowledge and hardware innovations fundamentally outshines the friction of adoption. It proves that this era is an unstoppable net positive for global society.
And my position is that the complete lack of technical standards and the, quite frankly, catastrophic corporate mismanagement of these tools represent systemic crises that cannot be ignored, and they threaten to turn this technological bounty into a massive economic and social disaster.
Let's set the baseline here. To truly understand where we are in mid-2026, we have to recognize that we have crossed a permanent threshold.
Sure.
The current era of cyber intelligence is not just an iterative software update. It's not just a new patch for your phone. It is a monumental leap forward that's fundamentally altering our physical and digital reality for the better. The agricultural super seasons are just one localized miracle of efficiency.
They're a great example, yeah.
But if you look at the broader landscape Lakeman outlines, the real triumph is the flourishing ecosystem of highly efficient, globally accessible, open-weight models. We are no longer waiting for a single monolithic corporation to hand down technological scraps from behind a paywall.
We do have a lot more players now.
We have a vibrant open ecosystem. We're looking at Google's Gemma models, European triumphs like Mistral, and an incredibly dominant suite of Chinese models that are natively bilingual and just highly efficient.
Oh, the raw computational power is definitely there.
Right. The power we now have on our local machines is accelerating science, medicine, and human thought in real time. The benefits to our collective intelligence undeniably outweigh the growing pains of implementation.
See, I will certainly grant you that the sheer availability of computational power is historically unprecedented. Nobody is arguing that the math isn't impressive.
Okay, good.
But having raw power is very different from having a functional infrastructure to actually wield it. The deployment of this technology across the global landscape is a structural nightmare.
A nightmare? That's a strong word.
It's the accurate word. We are operating in a digital Wild West completely devoid of technical standardization. You have profoundly powerful systems that fundamentally cannot communicate with one another at the architectural level.
Well, they can, it just takes some work.
But even worse than the technical fragmentation is the direct human cost. These fragmented models are being deployed for critical human evaluation, and they are trained on deeply biased human data.
We'll get into the training data, but
it's resulting in dictatorial character analysis that are actively costing people their livelihoods. And who is overseeing this transition? A corporate C-suite completely devoid of academic knowledge or cyber intelligence experience. They're buying into greedy marketing rather than making scientifically literate decisions.
Right, the enterprise sales trap.
Exactly. Technological brilliance is entirely moot if its deployment results in bankruptcies, suicides, and what the source material describes as Malthusian corporate skirmishes. We cannot separate the pristine algorithms from the disastrous frameworks governing their real-world use.
Okay, well, let's start by unpacking the sheer scale of the raw technological power we are dealing with here, because I think the structural chaos you're describing is simply the exhaust fumes of an incredibly fast engine.
Exhaust fumes can still choke you.
Fair enough, but if we look at the El Marina ranking data provided in the text, the shift in global AI dominance over a remarkably short period is staggering, and honestly, it explains why the infrastructure is playing catch-up.
The realignment is certainly dramatic, I'll give you that.
It's unprecedented. In July of 2024, the top of the leaderboard was basically an American monopoly. You had Google at number 1, Meta, NVIDIA, Cohere.
The usual suspects.
Right, but look at the trajectory by October 2025. It is a complete takeover by Chinese models. ZI.ai takes the number 1 spot, followed by Alibaba, DeepSeek, Moonshot AI. Meta and Google are pushed significantly down the ranks.
The landscape flipped incredibly fast.
And these aren't just incremental software improvements either. They are architectural paradigm shifts. Take DeepSeek V4 Pro, for example. We're talking about a 1.6 trillion parameter mixture of experts model.
Which is massive.
Yes, and to translate that for a second, it means the model isn't using all 1.6 trillion pathways for every single query, which would be computationally impossible, frankly. It dynamically routes questions to tiny, hyper-specialized subnetworks.
Right, it saves power that way.
Exactly. And this allows for a true 1 million token context window. A window that size means the AI isn't just reading a single research paper. It is holding an entire medical library and its active short-term memory simultaneously.
It's a huge leap in context retention.
It can connect disparate dots across thousands of documents that a human researcher could literally never hold in their brain at once. Add in Baichuan Omni, natively processing text, image, and video without needing a clunky translation layer, and you have a software revolution. But, and this is key, what really cements this as a net positive is the hardware revolution supporting it.
You're referring to the shift away from traditional silicon processing?
Exactly. For years, critics of AI have pointed to the massive energy draw of NVIDIA's silicon GPUs. Silicon uses electrons to transmit data. Electrons have mass and charge, which means they face resistance.
And resistance generates massive amounts of heat.
Yes, we spend gigawatts of power just cooling data centers down. But we are now seeing the mass production of Chinese photonic integrated circuits. They use light, photons, instead of electricity.
Which is mathematically brilliant.
Photons have no mass and generate virtually no heat. They are astronomically faster and operate at near zero energy cost. You combine that with the new flexible steel, and we have autonomous robotic systems and trains that can operate far longer without needing a recharge.
Right, requiring far fewer solar units to support them.
It is super efficient, it's ecologically friendly, and it solves the energy crisis that was supposed to bottleneck this entire industry. The raw scientific development here is a permanent elevation of our capabilities.
Okay, see, I come at it from a completely different way. I will not deny the physics. Bypassing the thermal limits of silicon via photonic circuits is a marvel of engineering. And DeepSeek's reinforcement learning is phenomenal for agentic tasks.
So you agree the science is a triumph.
But what good is a massive ecosystem of powerful, highly efficient, natively bilingual AI models if they fundamentally cannot speak to each other?
Well,
the text explicitly highlights a growing severe problem here, a total lack of standards. Standard organizations like the ISO and major tech institutes have been entirely asleep at the wheel.
they're just slow.
To understand why this matters, you have to look at how these models actually read text. We have brilliant systems from Anthropic, OpenAI, Google, and Zippo AI, but their tokenizers do not use the same ISO text standard.
Look, I think you have to expect a lack of standardization when the science is moving this quickly.
But the mechanism of that lack of standardization is paralyzing developers. Let me give you an analogy. It is exactly like the mid-19th century railroad boom.
Oh, the gauge widths?
Exactly. You had all these different private companies laying track at breakneck speed across the country. But every single company used a different track width, a different gauge. So a train full of cargo literally couldn't roll from one state into another without stopping, having every single piece of freight unloaded and manually reloaded onto a train with a different wheel width.
That sounds exhausting.
That is what we are doing with data right now. There are no token translators. So you have a Z to I model that might be the smartest reasoning engine on the planet. But getting its vector parameter data structures to interface smoothly with a local Mistral deployment is a colossal bottleneck. They are mathematically incompatible at the foundation.
I see why you think that, but let me give you a different perspective. The lack of ISO standardization is a feature of rapid innovation, not a bug.
A feature? That's quite a spin.
When you move at the speed of 1.6 trillion parameter leaps, you simply cannot wait for an international standards committee that meets, twice a year in Geneva to agree on a naming convention. Bureaucracy moves at the speed of human politics. Cyber intelligence moves at the speed of light.
Oh, come on. You're waiting for Geneva to save us.
No, I'm saying the result of ignoring the bureaucracy is a complete structural breakdown for the people actually trying to build on top of these models.
It's not a breakdown, it's just messy.
The source document calls it a vast time waster, and for good reason. If you were a developer trying to merge models to create dedicated context agents and specialized offspring, it is incredibly tricky because each provider uses entirely different naming conventions and mathematical scales for identical settings.
Like the temperature settings? Yes. One model's temperature, the setting that dictates how creative or chaotic its answers are, might operate on a completely different statistical curve than another's. You have to constantly interrogate several different LLM JSON outputs just to compare, combine, and resolve them.
Okay, but
You're constantly juggling and merging weights depending on the source LLM and the language. This fragmentation is actively stifling the progress you are championing because we are spending half our time building translation layers between the AI models instead of actually using them.
I'm not convinced by that line of reasoning because you're assuming the only way to achieve integration is through top-down bureaucratic standardization. You're waiting for the ISO to mandate a universal rail gauge, to use your analogy.
I'm waiting for some kind of sanity. Yes.
But the text shows us the ecosystem is already self-correcting natively. Yes, juggling interchange formats in JSON spaghetti is tricky right now, but look at what is emerging. Collaborative, open ownership development models.
Open source communities?
Exactly. These open source communities are specifically providing intelligent routing and specialized context systems. We don't need a slow-moving Geneva committee to mandate a token standard if the developer community simply builds an intelligent router that dynamically translates and selects the right expert offspring on the fly.
It's a band-aid.
The scientific community is bypassing the slow-moving institutions and solving the integration problem organically through better code.
I'm sorry, but I just don't buy that organic, open source self-correction is enough when we pivot from technical integration to human integration.
How so?
It is one thing to have an intelligent router sort out mismatched JSON output so an AI can write a Python script. It is an entirely different level of risk when these fragmented, mathematically misaligned models are unleashed on human beings.
Okay, I see where you're going.
And if we can't even get two models to agree on how to tokenize a comma, how can we possibly justify using them for what Lakeman warns is a big problem, scathing human character analysis?
You're referring to their deployment in corporate human resources.
Human resources, website administration, user profiling. We have moved far beyond the AI just answering trivia questions. These systems are actively judging human worth.
Judging is a strong word. They're evaluating data.
And the reality of this is brutal. If you use an LLM in private to sharpen your own arguments, that's perfectly fine. But when deployed as a selection process for employment, it is disastrous.
Because of the training data?
Yes, because the human training data under the hood is deeply structurally flawed. The text specifically calls out the demographic reality of early reinforcement learning. These foundational models were trained by, and I quote, sensitive, childish, bigoted, narrow-minded dorks who do not appreciate others' opinions.
That is a very direct quote from the text. Yes.
When you deploy that neural network into an HR department, it acts as a strict, antisocial, idealist, dictatorial belief system. It doesn't evaluate a candidate's resume objectively. It evaluates them based on the narrow, baked-in worldview of the human labelers who tuned its algorithms.
Which is problematic.
People are actively losing their livelihoods because they don't align with the rigid dogma of a poorly trained neural net. You cannot engineer your way out of human bigotry if it is structurally baked into the foundation of the model.
That's a highly compelling point, though. I would frame the root cause differently.
Oh, I'm sure you would.
The job displacement we are seeing and the clumsy, often dictatorial implementation by HR departments is not fundamentally a failure of the technology. It is a failure of human adaptability and institutional support.
So it's our fault for not adapting to the bigoted machine?
No. Let me offer an analogy based on the text's own historical reference. Think back to the transition in the modern office when the photocopier was introduced.
Okay.
Before the photocopier, you had entire floors of buildings dedicated to the typist pool. When the photocopier arrived, and later when bosses learned to type their own reports on early personal computers, the mechanism of document reproduction fundamentally changed.
Right, the typists were out of the job.
But those typists didn't just vanish into the ether, right? Their specific mechanical role became obsolete. Ideally, there should have been opportunities schemes and retraining programs. Typists needed to evolve into personal assistants or move into more creative, strategic positions.
I'm not sure I see how this connects to dictatorial AI.
The AI job displacement we are witnessing is exactly the same mechanism. The technology is doing exactly what it was designed to do: evaluate data instantly. The failure is the lack of societal repurposing and retraining programs to help workers transition up the abstraction ladder alongside the technology.
I appreciate the historical parallel, but there is a massive categorical difference there.
What is it?
The photocopier didn't evaluate the typist's psychological profile and fire them because it disagreed with their tone.
Well, no.
The photocopier was a passive, inert tool. These LLMs are active, dogmatic gatekeepers, wielding structural power over human lives.
But wait, the technology itself is already solving the exact dogmatism you're worried about.
How?
The strict, rigid behavior is an artifact of older legacy methods of human training. The better LLMs, the ones actually driving this era forward, are utilizing self-teaching mechanisms to bypass their original programming. They use RAG, Retrieval Augmented Generation.
RAG is definitely changing the architecture.
Let's explain why that matters. Instead of the AI answering an HR question based solely on the potentially biased neural weights it memorized from human labelers, RAG forces the model to halt, query an external, verified database, and ground its reasoning in objective facts before generating a response.
Which assumes the database is objective.
It structurally anchors the model outside of its own biased training. By grounding their reasoning in external data retrieval, these models broaden their knowledge and bypass the narrow-mindedness of their original creators. The technology is literally outgrowing our human flaws.
That is an incredibly optimistic view of RAG. And frankly, it assumes that the people purchasing and deploying these systems understand the architectural difference between a legacy biased neural net and a RAG-enabled system grounded in objective data.
Which they often don't.
And this brings us right to the ultimate fatal structural failure: corporate incompetence at the enterprise level. Even if the open source developer community miraculously builds intelligent routers to solve the technical bottlenecks.
Right.
And even if RAG theoretically mitigates human bias, the decision makers holding the checkbooks are structurally unequipped to understand what they are buying.
You're targeting the corporate C-suite now.
Absolutely, because they are the ones enforcing the friction. The text hits this demographic incredibly hard. We are dealing with people in high places who have gotten to their positions not by rigorous intelligence, but by rising gracefully to their level of incompetence.
The Peter Principle in action.
Exactly. They are now sitting across from a box on their desk that is vastly smarter than they are, operating on mathematical principles they don't even pretend to understand. These C-level executives have no technical qualifications, no academic knowledge, and zero deep experience in cyber intelligence.
So they rely on vendors.
Yes. So what is the mechanism of adoption? They are easily tricked by the subversive integration and greedy marketing of massive enterprise systems. They buy the shiny, expensive, deeply flawed junk.
They purchase the massive enterprise package with the aggressive sales team, rather than utilizing the highly capable, natively efficient, open-weight models we discussed earlier, like the I-Series or GLM 4.5.
Precisely. And the results of that ignorance are catastrophic. We aren't just talking about a slight dip in quarterly enterprise efficiency.
No, the stakes are higher.
The text explicitly lists the downstream consequences of these uneducated purchases: bankruptcies, suicides through sudden job loss, and widespread social unrest. And worse, it triggers warring skirmishes between what the author calls greedy, hegemonic, Malthusian actors.
The resource wars.
Yes, these massive corporations, driven entirely by marketing panic and executive ignorance rather than scientific literacy, engage in resource wars and market squabbles that have painfully real economic effects on everybody outside their immediate bubble.
It is a messy transition.
It simply doesn't matter how incredible Alibaba's Quen model is or how perfectly RAG filters out bias. If the economic framework deploying the technology is ruled by Malthusian panic and executive incompetence, the structural failure is a deep rot that entirely ruins the technological triumph.
Okay, I will readily acknowledge the severity of the corporate malpractice.
Thank you.
The phenomenon of executives being bamboozled by enterprise sales pitches while ignoring free, mathematically superior open-weight models it's a profound frustration for anyone who actually understands the science.
It's maddening.
But I have to return to the ultimate thesis of the source material, which is stated unequivocally. Despite the junk being batted around by greedy enterprise marketing, despite the deeply unqualified C-suite executives making terrible purchasing decisions, and despite the very real pain of these hegemonic corporate squabbles, the core benefits to science, the raw development of knowledge, thought, and intelligence far outweigh the problems.
I just don't see how you balance that scale.
Think about the physical realities we've established today. The invention of zero-heat photonic circuits, the ecological salvation of highly efficient autonomous networks, the medical breakthroughs that will inevitably stem from models capable of connecting 1 million tokens of research simultaneously.
The potential is there, sure.
These represent a permanent, irreversible elevation of the human condition. The corporate mismanagement you are describing, while incredibly damaging, is a temporary, generational friction. The executives will retire, the companies will adapt or fail, but the science is forever.
I think temporary generational friction is a terrifyingly sanitized way to describe widespread bankruptcies, job loss, and social unrest.
It's looking at the macro timeline.
I agree that the scientific leaps themselves are breathtaking. A photonic circuit operating at near zero energy cost by transmitting light instead of electricity is an absolute marvel of physics.
It's brilliant.
But a scientific marvel governed by a broken social and economic system is an incredibly dangerous thing. We cannot afford to be so blinded by the brilliance of the machine intelligence that we ignore the profound stupidity of the human systems managing it.
Which is a valid concern.
If we don't demand rigorous architectural standards, if organizations like the ISO don't step up to create universal integration, and if we don't drastically overhaul how we educate our leadership and retrain our displaced workforce, the resulting social unrest will completely overshadow the scientific gains.
I think we have arrived at a very clarifying point of reflection here. Throughout our discussion today, my position has remained that the raw scientific breakthroughs, from Chinese photonic hardware to the staggering million-token capabilities of open-weight models like DeepSeek, Quen, and Mistral, represent an unstoppable net positive for global society.
Right.
The sheer mathematical velocity of innovation in mid-2026 is permanently rewriting what is possible for our species.
And my position remains that the brilliant potential of this technology is fundamentally threatened by the structural frameworks deploying it. Without rigorous, universal technical standards, without responsible HR retraining programs to manage displacement, and without scientifically literate corporate leadership, we are handing a miraculous, world-altering tool to Malthusian actors who will inevitably use it to cause severe social and economic damage.
Yet despite our different lenses, I think we have found a vital point of convergence today. The technological leaps themselves are undeniably real and entirely transformative. The shift in global AI dominance is a factual reality, And the architectural capabilities of these mixture of expert systems are truly breathtaking.
Oh, definitely.
We both seem to agree that the greatest threat to this era of progress is not the cyber intelligence itself, but the uneducated, unqualified human leadership attempting to forcefully integrate it into our lives.
I would agree with that completely. The box on the desk is brilliant. The person sitting behind it signing the checks is the variable we have to worry about.
Exactly.
It requires us as a society to hold two opposing perspectives at once. We must celebrate the breathtaking, raw scientific capability, but we must remain fiercely, relentlessly critical of the structural and economic frameworks governing its real-world use.
There is certainly much more to explore in Professor Lakeman's document. We didn't even have time today to fully dive into the specific multimodal operations of NVIDIA's Nematron family, or to dissect the incredible natural language writing capabilities of Moonshot AI's Kimi K2 series.
We barely scratched the surface.
For those following the deep technical specifics, the document's granular analysis of these individual models is essential reading.
It really is. The nuanced architectural differences between those specific models dictate so much of the macro-level economic impact we've been trying to unpack today.
As we sign off, I find myself thinking back to those mid-2026 agricultural centers we started with, the artificial super seasons, 10 crops a year, completely overriding the ancient natural rhythm of the earth.
It's a new world.
We had finally built the tools to rewrite the seasons, to rewrite the boundaries of our active memory, and to permanently elevate our own intelligence. The question that remains isn't whether the harvest will come. The science guarantees the harvest.
But do we have the wisdom to manage it?
That is the question. We will leave you to weigh that for yourselves.